Hello friends, how are you doing? Today we will discuss about an abstract classes. Before going through to discuss an abstract class, first, we should know why we need an abstract class. First you should know the need, its uses and how to implement it your application. Suppose you have learned in math about trigonometry ratios sine, cosine, tangent, but if you don't know actually where this formula is used in real world then it is useless. Now first question should come in mind, why do we need an abstract class? Abstract classes provide a blueprint to be followed by the classes that extend the abstract class. Abstract class because it gives a predefined template for any future specific class that you might need. Suppose you want to develop a shape app. The app will perform similar functions for all types of shapes, with some differences in their implementations. We can have two classes, circle and rectangle, to calculate the area of both the shapes. Using abstract class, you can enforce a set of methods that must be implemented by both the classes circle and rectangle. Hence, the abstract class provides a blueprint for these child classes. An abstract class can be used as a type of template for other classes. The abstract class will hold common functionalities for all classes that extend it. The purpose of an abstract is to provide a concise and accurate description of the study, allowing readers to quickly understand the main points without having to read the entire document. We'll discuss later with running example. Let's do it in practical. We created an abstract class shape. Also created subclasses circle and rectangle of shape class. Now run the program to see output. Below the output /result is shown. Now, we put the breakpoint in the code and run the program in debug mode. And see the sequence of code running by pressing F8. Now you better understand how abstract class work. Shape is an abstract class with an abstract method calculate area. The abstract keyword indicates that this class cannot be instantiated directly, and any concrete subclass must provide an implementation for the calculate area method. Circle and rectangle are concrete subclasses of shape. They provide specific implementations for the calculate area method. Last look at the abstract class. We created one abstract property, one abstract method and one non-abstract method. Let's create an abstract class in Kotlin that models a mother instructing/setting some predefined rules for her two children to study according to their respective schools. We'll define an abstract class called mother with two child classes, school A child and school B child, each representing a child attending a different school. Abstraction is the practice of hiding internal details and showing only the functionality. It is one of the key concepts in the object-oriented programming paradigm. An abstract method does not contain any body. Abstract classes provide a way to reuse code by allowing multiple classes to extend the same abstract class and share the same abstract methods and properties. Abstract classes can be used to create a loosely coupled structure. There are various benefits of loose coupling. Easy maintenance of the code. Changes can be made to one class without affecting other classes. Testing of loosely coupled structures is easier as we can divide the project into small modules and perform unit testing. In loose coupling, a method or class is almost independent and less dependent on each other. If we wish to create many versions of our component, we ought to utilize an abstract class. With abstract classes, versioning our components is easy and straightforward. When the base class is updated, all inheriting classes are updated automatically as well. Conversely, an interface cannot be altered once it has been created. Every time a new version of an interface is needed, we have to start from scratch with the design. If we want the same implemented functionality across all of our components implementations, we should use an abstract class. While abstract classes enable us to partially implement our class. Abstract classes are used to provide a generalization of behavior that can be inherited by subclasses. By using an abstract class, you can ensure that all subclasses share a common structure, promoting consistency and reducing the amount of duplicate code. Example, generalize the functions/fields that many types can have. Like for our shape class, we can create it as an abstract class and generalize the behavior of a shape, like height, breadth, area, etc., and then create particular subclasses extending that general shape's functions and fields. In the code snippet, here, we created general information that only shapes can have. Rules for using abstract class. You have to use the keyword abstract. You cannot instantiate an abstract class. This means you cannot create an object in the abstract class. So, imagine, if you create an object of that abstract class and try to access one of the abstract methods, it will throw an error because there is nothing inside the method to perform. The following error will be seen if one tries to create an object of an abstract class mother. An abstract class can contain both abstract and non-abstract methods. You can include non-abstract final methods, a method that cannot be overridden as well in your abstract class. Final methods in abstract classes cannot be abstract. They must be implemented in the abstract class itself. You can also include constructors and non-abstract static methods in your abstract class. Let's see the calculator app example. You create an abstract class, calculator, and you need the basic 4 functions, addition, subtraction, multiplication, and division. You declare these as abstract methods inside the calculator class. In the example above, the calculator class defines an abstract method call, which must be implemented by any subclass. The add class overrides this method to perform addition. Elements abstract class can have 1. Data member 2. Abstract method 3. Method body, non-abstract method 4. Constructor 5. Main function method. Can an abstract class have a final method? The answer is yes. Classes that extend game would still need to implement all abstract methods, but they'd be unable to extend play one game because it is declared final. Final method cannot be abstract itself. Other non-final methods in the same class can be. But, any abstract method in the class can't be declared final. It will give a legal combination of modifiers, abstract and final error. Kotlin Abstract Class Constructor. In Kotlin, abstract classes can have constructors, and they can be used to initialize properties and perform other necessary setup when an instance of a subclass is created. Abstract class constructors work similarly to constructors in regular classes, but there are some important considerations. Abstract classes with constructors. An abstract class can have one or more constructors. These constructors can be primary constructors or secondary constructors. The primary constructor is defined in the class header, while secondary constructors are defined inside the class body. Primary constructor. When you declare a primary constructor in an abstract class, you can provide default values for constructor parameters, just like in regular classes. Subclasses must call the primary constructor of the abstract class when creating instances of the subclass. Here's an example. In this example, the vehicle abstract class has a primary constructor with two parameters, name and year. The year parameter has a default value. The bike subclass must call the primary constructor of the vehicle class when creating instances of bike. Secondary constructors. You can also define secondary constructors in an abstract class. Subclasses can choose to call these secondary constructors if needed in addition to or instead of the primary constructor. Example with a secondary constructor. In this example, the animal abstract class has a secondary constructor that takes an additional age parameter. The primary constructor is still called via this name in the secondary constructor. Remember that when you create a subclass of an abstract class, you must provide implementations for any abstract members, properties or methods, declared in the abstract class, and you should call the appropriate constructor of the abstract class using super in the subclass constructor. One more example of abstract class student fees. Please go through it and see how it works. Now, you better understand about the purpose of creating an abstract class. One more example of abstract class student fees. Please go through it and see how it works. Now, you better understand about the purpose of creating an abstract class.